So what I'd like to do for you today is to share with you a tool that can get rid of a gaping blind spot in the way we look at the performance of our application. Okay? So this is a tool that you can use tomorrow to really get a tons better understanding of your performance data than you've ever had before. It's a very exciting thing. Okay. And what we're going to do is we're going to do a better job of comparing the results of today's performance test, the performance test that's right in front of you. We're going to do a better job of comparing that data to what you've done in the past, maybe from a previous build, or maybe from a previous release. So this is a little bit about me. I published a book in October. And in that book, I really had to think, well, am I really qualified to write this book? And the thing that I thought made me the most qualified was how I asked to be introduced, is because I've wasted a ton of time with, I don't know, really poorly designed performance tools. And a lot of times you walk up to a system in your world and there's not enough monitoring. And there's not enough data to show that there's a performance defect. But it's right there. It's happening right in front of you, that defect. But there's not enough monitoring. That's so incredibly frustrating. So you have to shut it down, add some parameters, configure, maybe install a new tool, something like that. Maybe you're adding garbage collection parameters or something like that. Then you have to restart the application, reproduce the problem, capture the data, and test. So that time is completely wasted. I just feel like that's what I get paid to do. It's busy work, right? In dealing with poorly designed tools with inconvenient access to data. So I've done a ton of that, right? I've wasted tons of time. And this tool is one thing to get just a little bit beyond that. So that's a link to my book on Amazon there on the top left. Down here on the bottom left, I guess I've been pretty busy. I authored a Java performance exam that you can take at this website. It's pretty cheap. I think it's like $30 or something like that. So if you are interviewing people that are going to come in and do Java performance analysis work for you, and you give them this test, let's say it's 3 people, you give those 3 people this test, you're going to know a lot after seeing their results about what these people know about performance. So I hope that test can provide value that way. And then here's my other contact information. Okay, so here's the GitHub repository where this tool here is up at the top of the screen. And this is just a quick agenda of what we're going to do. We're a little short on time, so I'm just going to breeze through this. So I'm going to start off topic a little bit. And we're going to talk about motivations, about why does anybody care? Why is this even important? And we'll talk about the 2 main use cases where I see this being helpful. And then I'm going to dip out of my comfort zone, and we're going to talk a little bit about the architecture of the tool. I've got that much. I've got the architecture of the tool. It's Docker that I'm not that comfortable with. So this was my first foray into the Docker world. So I'm not doing like rocket science Docker here. This is basic bones stuff. Can I have a show of hands, people who have spent some time putting together Docker deployments? Yeah, so maybe half the folks. That's great. My guess is y'all are going to know more than I do about this topic. But this is a Docker deployed solution, right? I'm leveraging a few other containers that are already pre-built. I think it's a great use case for how Docker can be helpful. And then we'll see if we can do a demo, and we'll talk about how this can be helpful going forward. So motivations. This is where I go off topic. So these are some of my frustrations with monitoring, right? You don't have security access to get to a machine. So how do you know what particular thing is slowing it down if you don't have access? That's a royal pain. Maybe you don't have a license for that great performance monitoring tool. Maybe it's AppDynamics. Maybe it's Dynatrace or New Relic or something like that. Maybe you didn't have a profiler hooked up. Who knows? Okay, there are lots of deficits in our monitoring these days. And for me, what I think about going over and over again about this, it's that when it's too hard to get those metrics, people don't collect them, right? And the systems just end up being slow. So that's a big lesson learned for me. And we'll talk about how that impacts today's talk. So I'm going to jump tangents again. I'm going to go into a separate topic that's also a motivation for me. So in my book, I talk about which persistence pattern works better. And when I talk about persistence, I'm just talking about how do you structure your calls to a database. If you have a chunky approach, right, with fewer calls, is that going to be faster? Or is it a chatty call? If you make like a ton of really small requests with just a single result, which of those is going to be faster? Okay, so I've always wondered this, and I coded up 5 different implementations of various layers, various chunkiness and various chattiness, and I've got those out on a GitHub repository. I think I have a link here in a slide or two. So I really wanted to see, how chunky do you have to get to make things perform well or to perform poorly? Which is it? Chunky, does chunky go faster or does chatty go faster? So I had 5 different code samples. They all implemented the same use case, which was just a simple account inquiry. So what I did is I started to put together graphs like this. So these are the first 2 results from scenario number 1 and scenario number 2. We're not going to delve into the details here. And this is throughput, right? So higher numbers are better. So which scenario is better here? Let's see. You know what? I really need my laser pointer. One moment, please. Okay, better. Can we do this? Okay, so here's scenario number 1, here's scenario number 2. We're over here at 180, we're here at 400, right? So this scenario is better, right? Higher throughput is better and faster. So that's nice, but I had 5 scenarios, okay? And here's kind of what I call a SQL sequence diagram of each of these 5 scenarios. And this one over here, number 5, this was the chattiest. This is cut off the screen. There were like 100 some odd calls here to the database. So this is the chattiest over here on the right. And this is the chunkiest, okay? So when you have 5 graphs like this gets ugly. This is nasty. I've got 1, 2, 3. They didn't even all fit on the screen here. So how do you easily make comparisons about this data? I did a Java 1 presentation in the fall, and I didn't have 5 tests. I had several dozen tests I had to compare, okay? And compiling all that data and making decent, reasonable comparisons between those tests and trying to present them in a coherent way to my audience, oh my gosh, I broke my back trying to assemble that data to get it into a meaningful format, okay? So that's my motivation for this tool. Drawing meaningful comparisons between performance data is a royal pain. And it's a problem because it's something we should regularly be doing, right? To understand what implementation is going to be more beneficial. Faster, right? So I just want to just get real specific about what I'm talking about. So, you know, the vertical axes have different max values, right? We're over here at 400, that's 300, that's 200. Managing the multiple files, fitting all the graphs on one screen, and of course you could summarize all this, right? You could manually pick through, find the right data points, dump it in an Excel spreadsheet, and be done with it, right? But still, it's a pain, it's extra work. So that's where I'm coming from. This is the motivation for this data. So I mentioned earlier, when metrics are difficult to collect, they don't get collected, right? That was my first conclusion that I shared with you. And I think there's a correlate. It's when graphs are difficult to create, they don't get created. It doesn't happen. And we, as software engineers, we know how to run comparable tests, right? You take two systems, and maybe you want to compare database implementations, or maybe versions of your code, right? You're changing one element in your test, so you can see which one impacts performance in the best or the worst way, okay? So those are the comparisons that we know how to do, right? These are apples to apples comparisons. And when these comparisons are difficult, those comparisons don't get made either, right? And it's partially because of a data presentation idea. I can run these tests, and I know in my head that, yeah, the chattiest test is going to be real slow. But I need to present that to my peers, to you all, to my team, or whoever, to make a compelling case going forward of, yeah, this is how it is. Chatty is generally a very slow database strategy. So we need to circulate this data amongst ourselves, and putting the right graphs together is an important part of that. Okay, so tools that enable comparisons are inherently better. And why? It's because they avoid a blind spot. And the blind spot is essentially, so here I'm going to jump into the realm of my work. You know, I work at FIS. We deliver financial services software. We have several hundred products. We're a large company. And when we analyze performance data, we run load generators, right, to stress the systems out. We try to get a relatively realistic workload. And when someone asks us our opinion about the performance of a particular test, there we are. We're hunched over the results. The load generator spit out a report, and we are focused, right? It's that report. That's the data. But what about the test that ran last night? What about the in the automated build? Or what about the test that happened last week? What about the performance in the previous release? Okay? Is this performance that I'm sitting here looking at, that I'm focused on, how does that compare to what we did in the last release? Okay? So I think people mistake performance expertise. I generally have, you know, so give me an application X, right? Maybe an application that I've worked with for a few years. I kind of know the history of that application. I know its throughput, I know its response time, and I know that it's finicky about heap issues that you mentioned, perhaps. I know those things, okay? Just because of my proximity, right? It's not because I'm the expert, it's because I've seen the numbers before. So what if people who are not performance experts like myself, what if the architects, what if even the developers could just look? It would be brain dead simple to say, oh look, it's twice as slow as it was last night. You don't need a performance analyst to tell you that, right? If the comparison is made in a very direct and straightforward fashion, like in an apples to apples comparisons, okay? So I picture two main use cases for this tool. And the first is for the architect, right? It's for us at this SATURN conference. And generally an attentive architect that cares about making these meaningful comparisons. Okay? And I'm just repeating my data here, right? We want to check out how does this implementation's performance compare to that? And let's do several implementations, right? Let's try a handful of them. Okay, so that's use case number 1, is comparing multiple implementations. So here we are. Whoops. Excuse me, pardon me. Here we go. Okay. So this is a screenshot from the tool, from the ApplestoApples tool. I'm going to put this down so I don't accidentally hit it again. So what we see here is we see all 5 database strategies, right? I had 5 separate graphs before, all in a separate PNG file. They're tough to picture. And here, I just ran these tests with a carefully configured load generator. And the tool found the start times of these 5 tests. It lined them all up and put them on the screen. How difficult is that? Okay? There are some tools out there that do this already. You've got APM tools. I know Dynatrace is capable of this, but you have to dig long and hard to find, you know, the 8 buttons to press to line up the metrics just right. I think this should be our primary focus of looking at our data, of comparing the tests you run now to the tests you have in the past. Okay? So here we have 1 series for each of the 5. Okay? And database strategy number 2, this has the highest throughput, 412 requests per second. Okay? And that's the number, that's the series way up here at the top. Okay? So this is what we're looking for. Use case number 2 is the nightly build. Okay? Maybe a DevOps engineer or someone focusing on performance automation. Okay? In this use case, I'm not comparing different implementations. I'm just looking for what happened in last night's build, right? Did someone commit a change that just made performance go horrible? Okay? So here, performance remains pretty much unchanged over many builds, right? All these lines of response time are pretty much on par with each other. Here are the names of the 1, 2, 3, 4 different builds I'm tracking here, and throughput is pretty much the same, okay? Whoops. Here in these graphs, you can see the performance degraded severely in the most recent test. Okay, so this line up here, again, this is the response time graph, and this data is off the charts, right? And then down here in throughput, this is an outlier here, or a low liar, whatever you want to call it, right? So this is what we're looking for when you want to raise a red flag, say, stop the bus. Somebody committed something to the Git repository that's slowing things down. This is the moment that we're looking for. This is how you gain value out of this kind of tool. Without this, someone has to go back and actually understand what happened last night in a very detailed way, which is a really tough ask. Okay, but there is competition, right? There are some tools that do similar things to that, to this. So, for instance, the Jenkins performance plugin. Can I have a show of hands? Who spent some time with this? Kurt here? Okay. This is intended to do a very similar thing, right? When I said, whoa, stop the bus, we need to see what got committed last night that caused problems. The Jenkins performance plugin aims to do the exact same thing, okay? But in my mind, it's a very data-starved approach to getting that same data, okay? So the Jenkins performance plugin approach goes like this. So down here at the bottom, we have numbers 28, 29, 30, blah, 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 up to 37, okay? And each data point here is a summarization of the response time of every request that night in that particular test, okay? So here, so let's say this is last night's data, test 37. This goes over to 300 milliseconds. Okay, so 300 milliseconds was the average response time in last night's test. Okay, well, were there any ugly spikes in that test, right? Did the test perhaps die after the first few minutes? I don't know, it's just a little average number, that's all it is, right? If you go back to this, you can see that, yep, each of these tests lasted the same duration. Those are good, right? So this is a more data-rich understanding of what's going on in your nightly build, okay? So this really is the right idea. It's the right use case. You need somebody or some tool or some graph to say, whoa, stop the bus, right? We need someone to do that. Somebody's got to step up and do that. But this is just lacking, right? I'm the guy who wants more data, more understanding of what's going on, and a single data point from an entire test, that's not enough, in my opinion, to understand what's going on. Okay, there's no ability to pan and zoom here, and the data store for all this is in XML. It's kind of proprietary under the covers. It's just very limiting. Okay, second piece of competition is the JMeter Plugin merge results tool. Show of hands, has anybody used this? Okay. This is what I did for my Java 1 presentation. I mentioned that I had dozens of tests that I had to combine and compile. It took me hours. I mean, I almost had a health crisis trying to get this together in time for the presentation. It was horrible. This is the right idea, right? Here we're taking these two graphs, we're trying to put it on a single graph where we can compare these things. It's just too much work, okay? So let's talk about the architecture of this tool a little bit. So for starters, this is all built on the concept of what's called a Grafana scripted dashboard. Okay, so here's Grafana, right, this funny little symbol right here, and this is kind of the documentation for essentially the architecture that we're using. I'm going to jump back real quick, just to level set real quickly. What is Grafana? Okay, Grafana is a dashboarding solution. It's an incredible dashboarding solution. This is it here. You can see in the Chrome tab. We have two graphs, two rectangles, one on top of the other. It allows you to add graphs wherever you want and point to a data store, kind of a special data store, and pull those metrics from it, right? But you can get average, mean, 90% time, standard deviation, whatever you want. You build your graphs, the data is underlined, okay? I just wanted two graphs, so that's what I got. You build whatever graphs you need to. So that's the kind of tool that Grafana is. The usability is top-notch, incredible, and this is a fully open source product. Okay, so that's Grafana. Ta-da, right here, okay? So I mentioned this is a Docker delivered solution. So this is your OS. So for me, this is my MacBook. My MacBook is running Docker, and I have what's called a Docker compose file, right? It's docker-compose.yml. And this is the glue that ties together Grafana and the data store, which is InfluxDB, and then this piece that I'll talk about in a second. Does anybody have experience in this stack? I see a few nods out here. So for us, this has been incredibly easy to use, this tool set. But Influx, one piece of functionality that I have not been able to coerce it to do is this time shifting, right? So if I give you a test from last year, last night, and today, we need to normalize those dates on one date so we can display them all on a time series on the screen, okay? Influx doesn't have that facility, so there is this tool right here called the Time Shift Proxy that's available on GitHub. I don't have a link for you, sorry. It basically provides pre-processing for the Influx database SQL-like syntax that goes through here, okay? So here's how this works, just high-level overview. This is our load test. This is me and my 5 different scenarios, my chunky and chatty stuff, right? So I run scenario 1, bang, run the test using JMeter. Run scenario 2, 3, 4, and 5, okay? And here my code is getting stressed out, right? Some of the chunkies are going faster, some of the chatties are going slower. But all this time, JMeter, normally, in a regular configuration, it just writes data to a standard text file, right? It's normally called a JTL file, pretty basic. Can I have a show of hands for JMeter users? I'd say at least half, maybe a little more than half the people are signed up for that, so that's good. So the deal is, you can add some extra configuration to JMeter, point it to your Influx database, and the same data that was in the text file shows up in the Influx database, okay? So after you run your test, you go to your browser, you point it to Grafana, it loads the ApplestoApples.js, and that's my only contribution to this entire stack, okay? This is a lot of other people's code, and I didn't even do this, the time shift proxy, okay? So I was the one who coded this. So anyway, you go to your browser, you hit the Grafana URL, and the ApplestoApples.js, it decides what shows up in the dashboard, right? I showed you a Grafana dashboard with two rectangles, response time, throughput. In this scenario here, as described at this URL, ApplestoApples.js, it decides that there's going to be, what's going to go onto the dashboard. Is it going to be a this graph and a that graph or what, okay? So this is where the magic is done, where, how does this work? I do the calculation of the offsets, and then I ask the time shift proxy to tell Influx, give me all that data lined up on the same start time, on the same end time, so it can display nicely on a single graph. Okay, so that's the general architecture, and so here's the order. You go to the URL, okay? So that's kind of the ugly thing about the solution. This is not a beautiful solution. You start to launch this solution with a URL, and over here on the end, there's a parameter that I'm going to show you about that you'll need to add, okay? So you browse the Grafana URL. Grafana executes the ApplestoApples.js. It queries all the different run IDs of my scenarios 1, 2, 3, 4, and 5. It says, hey, you got 5 of these. That's great. Okay? And then in. Okay. Then it returns a dashboard with the time-shifted timestamps, the starts of each of these tests, whenever they were. And that dashboard is defined in a JSON structure. So that's what ApplestoApples is doing. It's returning a big JSON structure defined exactly like Grafana wants it. There's no official schema. That kind of stinks. You just kind of have to follow examples and reverse engineer. That's how it works best. Okay, so then what happens next? This is kind of weird. So now, it seems like it's all over. ApplestoApples has processed and it's finished, but the story is not over. At this time, the browser sends HTTP database queries here. Okay? So it's basically, Grafana is poised. It has all of these near SQL-like queries configured in it by ApplestoApples.js. Okay? And when you refresh your screen, so that's the first part, going to Grafana. Then it ships all of these SQL-like requests to here. Okay, and then they go to here. So your browser needs access to both of these things, and that's an important facet for the Docker deployment, because these 3 things right here, these are the externally available ports, right? There's tons of ports happening in here and listening, but my Docker compose.yml says, nope, we just need to expose this one, and this one to the outside world. Okay, so have a look at Grafana. You really need it. It's a great tool. So here's the install. Here's how it works. First you install Docker. Okay. It runs on Linux, and it runs on Mac, and it runs on Windows. And then this is a separate repository here that has all of the Docker Compose configuration files. Okay. Then you install JMeter, and you need this thing called the Plugin Manager. And let me go back to a slide real quick. So this right here, Novatech Backend Listener. This is a Java API that has batching skills, that knows how to batch requests, send their insert statements, their insert-like statements here. Okay, so that's what this is. Okay, and then this is the ApplestoApples.js file. We'll talk about this in a minute. You need to restart JMeter, and then I've got a sample plan, a sample test you can run. You don't need a system under test. You don't need a web server or anything. It runs its own little test. As long as you get the configuration right, point it to Influx to do those insert statements, we can get some nice data for you. So once you, so let's see. Yeah, so you restart JMeter, you run this file, and you run this test in JMeter for a few minutes, right? And when you're finished running the test, here's the URL that starts all of the magic, and here's the parameter at the end, okay? So in my JMX file that I have here, you have to name these tests, okay? You have to tell the tool specifically what you want to compare. You can imagine a team running tons and tons of tests in this system, and they're like, well, this isn't apples to apples, that's an orange, right? And that's a kumquat. These are different things. So the end user does have to play a role here, and they have to be smart about how they name these tests, okay? So when you provide a test name, I'm going to show you how to do that here in a minute, what you're saying is, when I name a test like this, like the fantastic load test, it's basically a series of tests, okay? And I'm going to have a run ID. Run number 1, run number 2, 3, 4, and 5. So that's how it works. When you want to see a bunch of tests on the same graph, you give it one name, and you repeat that name, the fantastic load test in this example. Okay, care and feeding. Let's talk about. So this is a brand new product, and I'm kind of picturing what it's going to take here to be a more full and robust product. Some of these things are done, and some of these are not done. I'll kind of share what is. So you want to back up your Influx database. We're at 10 minutes left. Is that right? Okay, great. Thanks. You're going to want to back up your Influx database. Load testing takes a lot of work and a lot of time. Okay, and that's basically money. So if you lose your data, right, that's a big deal. That's basically proof of what you've done. So backing up is important. So the Docker Compose scenario not only allows you to say, okay, these are the external ports, you can also say, these are the external volumes in one of these 3 containers you get to pick. And in my configuration, I say, bam, this is the one, this is the folder in the Influx container that needs to be backed up, right? So I tried to make that pretty straightforward. We'll see it in a second. If you restart the solution, is my data still there? Yes. The data will remain on the file system, and that's part of the reason it's because it's externalized. I won't go into that as detail. So I can imagine that if you do a lot of work in this area, you're going to say, well, this is a new solution. I'm not sure if I want to put all my eggs in one basket. Should I really trust all this? you can continue to write data to standard JMeter JTL files and write to the Influx database. So you can do both, right? You can you can have your cake and eat it too. Deleting tests. Boo-boos happen on a regular basis, load testing. That's one of the reasons why the Jenkins performance plugin is a problem. There's no convenient way to delete a test, right? If it shows up there, you had that graph, and it's like, well, how do you get the dang thing off there? ApplestoApples also does not have a way to get that off, but I have made available a query where you can go in and run some custom SQL and say, delete this, delete that. Okay? Retention is important. If you have an enterprise-wide repository like this, so let's say you stand one of these up, and this is your enterprise-wide repository, that's going to be a lot of data. Influx database is called it's a new breed of a database. It's called a time series database, and they're great about retention policies. Okay, so my default that I've installed here is just a 30-day retention policy. Okay, so if you want to make it longer, you can go into my up.sh file and change the 30 days to whatever you want. But what's really cool about this, and I don't have full support for this, you can have two different retention policies, right? When you bless a release of code, your team's been slaving and toiling, and you say, yes, performance is exactly how we want it. When you get that, you don't want to lose that data. That's gold. You need to keep that for a year, 2 years, 3 years, 5 years, something like that. So you can document. You can say, look, this was great performance. So the next time you release, I want performance to be just as great as it was. Well, you need to keep that data around so you can show people how good it was. Okay? So when you run a test on a release, you can reconfigure it to say, you know what? This needs to be on a different retention policy. So you can create two retention policies, have a 5-year retention policy, and have a 30-day retention policy. And when you cut that release, bang, keep that sucker for 5 years. Nightly tests, 30 days, something like that. And that will help to keep a DBA from having to get too involved in your work. Is there a question?
Yeah, I have a question. So how about instead of 5-year retention policies, you have kind of like a helping people learn? It deviates from the good policy, like from the good results?
So,
I wouldn't know that 5 years ago the performance was great. I just want to know that my next release is good or better as my previous release.
So it sounds like the question is, well, I'm not sure if I want to care about my 5-year-old test. I just want to know if my current test is good or bad. Is that basically what you're saying?
Yes, good, as good or better as the SLAs that you proved with the previous.
So you bring up SLAs, which is a real important concept. I've got 5 minutes left, and I still would like to do a quick demo, but this tool set can be great for helping to document your SLAs, whatever they are. So and again, this is not part of the solution I provided, just a quick disclaimer. But so we work with SLAs on a regular basis as well, performance SLAs. But where does that data come from, right? It comes from some poor soul toiling through the Apache access log to see how fast and how frequently the data flew on the busiest day of the year, and that's a lot of work to make that happen, especially when you have multiple products, multiple business processes in each product, et cetera, et cetera. But what if you can take those Apache access logs and push that data to this same stack? So at that point in time, you can take that SLA and say, okay, yeah, it's an SLA, but this is actual production data right here, and we're pushing, bang, this much throughput. So when you have a test, a load test, you need to say, well, how much load do we need to push? This much throughput right here. This is what we did in production at our peak. Of course, you want to get a little more sophisticated. You want the busiest hour of the busiest day of the year, right? So the point is really well taken, that you should really just be shooting for your target SLAs. But I still will assert that showing your history is very important to understand the progress of your product and whether you're headed in the right direction. Any other questions? Okay. So just real quick, this is what we're going to do. We're going to load JMeter, and when I say you need to carefully name your tests, you need to come in right here. Name your test here under this test name, under this backend listener. And here's the run ID for my scenario 5 right there, okay? So then when you go to look for that data, you stick it right over here. Test name, my first test. This is what I'm looking for. That's how these jigsaw puzzle pieces match up. Okay, so here we are with my rudimentary Docker skills. Okay, so I'm about to launch this up script. And the real interesting thing here is the starting point, where we go docker compose up -d. Okay, so while that's launching, I'm going to, what am I going to do? I'm going to launch JMeter. I am leaving tonight, so I do not have office hours scheduled.
Okay, because we have 1 minute left in the schedule.
Okay. So, come in here, name your test right here. My first test, I'm going to call this my first test X. And there's no great single message, but I recognize that as successful start. I'm going to run this. And we'll just run 2 short tests. Okay, so I'll try to, as we're waiting for this test to complete, try to wrap up my closing remarks. So performance takes a lot of work. Okay, so there's test number 1, and I forgot to look, but that started out as test 5. I'm going to name this next one, we'll call it test 10, or I'm sorry, run ID 10. So here we go back. I'm going to clear out these results, and we're going to run one more time. Okay, so for a day job, I train people how to load test to understand what the breaking points are in their system and how to find the things that are slow and to fix them. It takes a lot of work to collect these metrics. And if we can make this process easier of understanding your performance, of removing the blind spots, you don't want to, if you're focused just on one test, I think you're going to be missing a lot. So I think if we can make it easier for people to make these comparisons, when architects are comparing implementations, in our builds, when we have hordes of developers adding code, we need to understand the impact of performance of all those commits. This kind of tool can provide a great benefit. So here we are. We have the second load test completed. This is an awkward part. I have to go get my URL. Where's my URL? Localhost, and we call this my first test X. Okay, that's not where I wanted to go. I need to go to here. We load this data. We do have to sign in, admin and admin. Data source name.
I'm going to get you also version 2.
Okay. That's great. I appreciate your help.